Okay, so as I explained in my previous video, we were talking about the hypothesis testing. So as we said, we have something called hypotheses, and what we mean by hypotheses, we mean claims. Okay, so we're going to test whether these claims are correct or not correct. Okay. So we have the null and we have the alternative, as we said before. We use the estimator to compute what's called the test statistic. Okay, after you make the decision, you draw some conclusions about your data. We talked about the steps for testing of hypothesis. So we have to determine H node and H1, calculating the test statistic, comparing the value of the test statistic with the standardized value of Z, or the critical value. We call the value that we get from the table the critical value, or the tabulated value. Of course, the parameters that we are going to test in this course, we're going to talk about mu, pi, okay, mu1 minus mu2, and pi1 minus pi2. But when we are talking about pi1 and pi2, I'm not going to use this standard error. I'm going to talk about another standard error we're going to use later. Okay, so this is the one that we're going to use, because usually when we are talking about the difference between two population proportions, we're going to write our H node. Sometimes we're going to write our H node like this: pi1 minus pi2 is greater than or equal to 0 against, for example, less than 0. So this means I'm assuming that the two proportions are equal, because I'm assuming that the difference could be 0 or more. If the two proportions are equal, so this means since I'm assuming that they are equal, I have to force them to be equal in the sample, and this can only happen by calculating something called P bar. It's very similar to the pooled variance, okay? So I know that I have one population and a second population. From the two samples, I'm going to find the number of successes from the first sample plus the number of successes in the second sample divided by N1 plus N2. This will give me P bar. Once you get P bar, it's going to be your standard error is going to be of this form. And this is only going to be used when we are assuming that the difference is greater than or equal to 0. If it's not 0, then we're going to use this one. So this is only when we have 0 as of the value of the difference, not equal to 0. The difference is not equal to 0. Difference not equal to 0. Okay, of course, when you are making any conclusions, you can commit some errors. So what are the types of errors that we can commit here? We have two types of errors. Type 1 error, if we reject the null hypothesis. So let me show you this table. Okay, I have two possible decisions: reject H node or fail to reject H node. I have two claims. H node is correct. This could be a possible case, or H1 is correct. So if H node is correct and you reject H node, so this means you didn't make the right decision. But if H node is correct and you fail to reject, so this is one right decision. If H1 is correct and you reject H node, so this is one right decision. If H1 is correct and you fail to reject H node, so this means you have an error here, or you have committed an error here. So this means I can commit two types of errors: type 1 and type 2. What's the definition of type 1? You reject H node, this is the one, reject H node while H node is correct. And this will happen with a probability of alpha. So therefore, alpha is always something small because we care a lot about this probability. Okay, the other type of error is you fail to reject H node while H node, you fail to reject H node, so you accept H node while H1 is correct. So this occurs if we fail to reject the null hypothesis that is false. So, and we call this, the probability of this error, of committing this error, beta. Just two definitions that you should know. If the test, if you reject H node, we call the test a significant test. So when you are rejecting H node, you say that the test is significant. What do you mean by the test is significant? So what you see, what we mean by a significant test, so what you see from the sample is true. This is what we mean by a significant test. Because usually H1 is for testing what you see from the sample. What we see from the sample, which is usually different from H node. Okay, so we usually test if what we see from the sample is true or not true. I will show you how to write H node and H1 when we see the examples. But if it is significant at level 0.01, this implies that it's going to be significant at bigger significance levels. So this means if you reject at 0.01, so this means you're going to reject at 0.05 and 0.1. Okay. Some values to remember. These are the values that you can get from the table, but they are summarized here. So if you have a two-tailed test, this means you have two rejection areas. So in case we're talking about alpha equals 0.1, and it's going to be given in the question, so your value of z is going to be plus or minus 1.645. 0.01 is going to be 2.576, and so on. Now let's start reading the examples. A vice president in charge of sales for a large corporation claims that salespeople are averaging no more. So we get the claim from the question, okay, averaging no more. So we're talking about average, no more than means less than or equal 15. So there is a claim given in the question about having an average of less than or equal to 15. Sales contacts per week. He would like to increase this figure. As a check on his claim, 36, so I have a sample of size 36. So this means there is no need to think about any assumption for the population of this sample. And the number of contacts made by each is recorded for a single randomly selected week. The mean and the variance, so we have the mean and we have the variance, and we're going to use sigma instead of the variance, so it's going to be 3. Does the evidence contradict the vice president's claim? So his claim that they are averaging no more than. So do you think that the evidence, what we get from the sample, is against the president's claim or the vice president's claim? Now alpha is equal to 0.05. So now H node, in the question I have a claim that has the equal sign, so I'm going to place it in H node. Less than or equal, so this means I'm going just to choose H1 to be the opposite of H node, which is bigger than. The test statistic is x bar minus mu over s over root n. Why s? Because the sample variance is given in the question. So it's going to be 4. Rejection area is 0.05. Is it going to be a one-tailed test or a two-tailed test? So according to H1, it's going to be, the sign is pointing to the right, so I'm going to shade some area to the right. If I go back to the previous page, so one tail right, 0.05, so the value is going to be 1.645. So this means I have 1.645. So my next step is to locate this 4. So this 4 is located in the shaded area or the rejection area. So this means my decision is reject H node. You can write, since 4 is bigger than 1.645, so it's far away from my claim, then I'm going to reject the claim. So I rejected H node, so this means I'm assuming that H node is false, and I'm accepting, or I'm with the other claim that they are averaging more than 15. So what do you think about this vice president's claim? So we're going to disagree with his claim. So we rejected H node, so that then at alpha equals 0.05, and based on our sample results, we conclude that the salespeople are not averaging no more than 15. So we disagree with his claim. Next example. A machine in a factory must be repaired if it produces more than 10% defectives. So this means pi more than, okay, how did I know that they are talking about a proportion? It's from the wording of the question. I have 10%, it's a percentage of defectives. So pi is bigger than 10%, 0.1. Among the large lot of items it produces in a day, a random sample of 100, so n is equal to 100, from the day's production contains 15 defectives, so here is x. So I am interested in the number of defectives. And the supervisor says that the machine must be repaired. Does the sample evidence support his decision? Alpha is equal to 0.01. So what's going to be my H node? So look at the question, or look at the claim given in the question. This claim doesn't have the equal sign, so I'm going to place it in H1. And H node is going to be the opposite of this one. Then I'm going to calculate the test statistics. So it's going to be P. What I get from the sample is 15 over 100. So it's 0.15 minus pi. It's the value given in the question. And in the denominator, we use pi, not P. Now the value of pi is 1.67. We need to define the rejection area. Also this time, the rejection area is to the right. But it's one tail test, so I'm going to one tail right and 0.01. So the value is going to be 2.33. So here I'm going to use 2.33. Okay, 2.33. This is my rejection area. Where is 1.67? 1.67 is 1.67 is here. 1.67 is here. So my decision is, it doesn't fall in the rejection area. It is in the blank area. So my decision is fail to reject H node. So the conclusion, I failed to reject. So this is correct and this is false. So this means we failed to reject H node. So I'm against the claim that the percentage of, so the machine doesn't any repair. So I don't think that the machine needs any repair. Okay. Next, a psychological study was conducted to compare the reaction times of men and women to a stimulus. Independent random samples of 50 men and 50 women were employed in the experiment. So this means I'm going to have two populations, N of men and N of women. The men have a sample of, the men have a sample mean of 3.6. So this is X bar M, sample variance of 0.18. So do we need to think about using the t-table? No, because the sample sizes are already bigger than 30. And the women have a sample of mean 3.8 and a standard deviation or the variance of 0.14. Do the data present sufficient evidence to suggest a difference between true mean reaction times for men and women? Use alpha equals to 0.05. Difference, is there a difference? So this means equal against not equal. Of course, when we are talking about two populations, you have to write your test, your hypothesis in a form of a difference. So it has to be mu of men. So we talk mu of men not equal to mu of women. So this means mu of men minus mu of women is equal to 0. Again, it's not equal to 0. How do we write the test statistic? Go back to the table. And as you can see, mu1 minus mu2. So here is going to be my numerator. I'm assuming that the difference is going to be 0. So this is your numerator. The value of the difference from the two samples minus the difference that you are assuming between the two population means, divided by the standard error, which is this one. But of course, we're going to replace these sigmas with S. And this is what I did here. Okay, so under the root, you don't need to square root 0.18 and 0.14. You're going just to use them as they are here. So the test statistic is negative 2.5. As you can see, H1 is not equal. So this means we have a two-tailed test. So I'm talking about 0.05. So I'm going to have here negative 1.96 and 1.96. Where did I get it from? I got it from this table. Two-tailed test, 0.05, so the values are negative and positive 1.96. So if your test statistic is negative 2.5, so it's falling here. So this means I'm rejecting H node. Okay. This is 1.96. This 8 is wrong. So it's falling in the rejection area, so we reject H node. Reject H node. So H node is false. H1 I'm going to consider it true. So this means there is a difference between men and women in their reaction times, in their average of the reaction times to the stimulus. Next example. Okay. As part of her senior project, a marketing major at North Texas State University in Denton, Texas, surveyed 100 men and 100 women. At a local shopping mall, regarding their buying habits. Of men, we have 79 said they had used a credit card to make a purchase over $10 in the past months, while 84 out of 100 women admitted to this type of purchase. So our parameter of int is going to be the proportion of using the credit card to make a purchase. Okay? Add 5% level of significance. Does this support the claim that women are more likely to use credit? So that's what we're going to write. Women greater than men. I'm going to write this in a form of a difference. Women are more likely women are more likely. So greater than 0 doesn't have the equal sign, so I am going to put it here, and this is going to be the opposite of this one. Since the difference here for the two proportions is 0, then this means I have to calculate P bar. And P bar is going to be 100 plus 100. And on the top, I have 79 plus 84. And you calculate your P bar, which is 0.815. And then you calculate your test statistic. Of course, greater than, so this means your rejection area is to the right. 5%, so the value of Z is going to be 1.645. This 0.91 is falling in the blank area, so this means I'm going to fail to reject H node. Okay, so this means this is correct and this is incorrect. And in this case, I'm going to say that I don't agree that the women are more likely to use the credit card. So we are against this claim. Okay. Okay. This question is very similar to the one that we had in the confidence intervals, and I'm going to solve it in class. Here we have a smaller sample size, so this means we're going to use the t-table with some degrees of freedom. Okay, so I'm going to solve this in class. The last question, also it's about the t-table, and I'm going to solve